We are now on episode 8 of our fundamental trig identities. I highly, highly, highly recommend watching these in order. They are going to build in difficulty. And so this verification is quite a bit more difficult than the one before. And that one was more difficult than the one before, and so forth. And so as we get into these episodes, they're going to get more and more challenging along the way. So I would highly recommend watching them in order, starting from episode 1, where we build what the fundamental identities are, and then coming all the way through. So we are going to verify. And in order to verify, you need to pick the more complicated side. Up to this point, our more complicated side has been on the left every time, but it's not on the left this time. When you look, this is definitely more complicated than that. So we are going to start right here on the more complicated side. And we actually worked through a simplification of this in a previous video. So we are going to start on this right-hand side, and our entire goal is to make it look like this side over here. And when we have done that, we have verified this trig identity. So we're going to start on the right-hand side, and I'm going to rewrite it just so I have a little bit more room to show my work. So when I am working through this, the first thing I notice is I have fractions that are being added. In order to add fractions, I need to get a common denominator. In a previous video, we talked about the easiest way to get the common denominator is to multiply this denominator to this fraction, and then to multiply this denominator to this fraction. So the way that that looks is I'm going to multiply by 1 plus sine of beta over 1 plus sine of beta. I'm allowed to do that because this is just 1. And you can multiply anything by 1 and it keeps the expression equivalent. So I'm going to multiply by that on this side, and then on the other side, I'm going to multiply by 1 minus sine of beta over 1 minus sine of beta. And again, I'm allowed to multiply by 1 minus sine of beta over 1 minus sine of beta because it's just 1. So I have not altered the integrity of our expression whatsoever. I've kept it equivalent. Okay, so now it's the simplification process of it. I need to multiply these two things together. So I'm going to multiply 1 plus sine of beta times 1. Well, 1 plus sine of beta times 1 is just 1 plus sine of beta. Then I need to multiply these two things together. Remember that really 1 plus sine of beta is tied together and 1 minus sine of beta is tied together. So reasonably speaking, you should actually have a set of parentheses there. That's a really weird pen, but it was kind of fun. Hopefully you recognize at this point that this is a difference of squares. And I went through that in a previous video as well. So I'm not going to go through the whole foiling process because I did it before. But 1 plus sine of beta times 1 minus sine of beta is a difference of squares. This turns into 1 minus sine squared of beta. And if you don't know how I did that, please go back and watch that previous video again. Okay, so now we're going to go on to our other side. And the other side, now we're going to start with 1 minus sine of beta times 1. Well, anything times 1 is itself, so this is 1 minus sine of beta. And that's all going to be over. Again, this is a difference of squares, and it should be 1 minus sine squared of beta. Okay, this is perfect. We now have the same denominator. Because we have the same denominator, we can go ahead and we can add our fractions. So when we add our fractions, you can add your ones together, and 1 plus 1 is 2. And you can add your positive sign and your negative sign together, which cancels out into 0. And then your new denominator is this 1 minus sine squared of beta. Already, this is significantly simpler than what we started with. We only have one fraction. Our numerator is just a number. Things are looking pretty good so far. However, I'm not done until my answer is in that format. I am not done until my answer is 2 secant squared of beta. So I've got a little bit more work to do. Now, in my head, I'm thinking about what is secant squared of beta? What is secant squared? And I'm going to look right here, and I know that secant is the same thing as 1 over cosine. Is there any way for me to get a cosine in my denominator? Oh my gosh, there it is right there. And I have these memorized. I have them memorized, and so they pop out on the page to me. But if you look right here, 1 minus sine squared of x is cosine squared of x. So I can replace that right there with a cosine squared of beta. Now, knowing what I know about fractions, this is the same thing as 2 over 1 times 1 over cosine squared of beta. I don't always write it like that because it's silly, but that's the same thing because 2 times 1 is 2 and 1 times cosine squared of beta is cosine squared of beta. What I do is every time I see a trig ratio, a trig function in my denominator, I ask myself, how can I move that into my numerator? I have a cosine in my denominator. It's right here. In the numerator, that would be a secant. So the 2 stays there, and that cosine squared of beta turns into a secant squared of beta. And now I have that same answer that I started with. That's my final answer right there. I say, woohoo! And I'm so proud of myself because I was able to work through this question.